Math 1314, Section IC1, Spring 2022, Tyler Junior College, Section 5.4, Linear Equations in Two Variables, Video 3, Slope-intercept form of the equation of a line. So far, we've talked about the slope of a line, which can be interpreted as rise over run. There's even a formula for it. Just a reminder, the formula for slope is m equals y2 minus y1 over x2 minus x1. And we will be using that at some point during this video. And also recall that we've talked about a form of a line called standard form. We'll review standard form here in just a second, but there's a problem with standard form. It doesn't tell you much information. So far, the only form we've seen is for the equation of a line is standard form, which was ax plus by equals c, where a, b, and c are any real numbers. This includes the possibility of a, b, or c being 0. But this form really contains no information about a line, such as its slope or intercepts. Now, don't get me wrong. If I give you some random equation like 2x minus 3y equals 12, we've already discussed how to find the intercept, so we're going to review that in a moment. And there is a way to coax the slope out of it, because recall, we only need two ordered pairs to stick into the slope formula, and if we find the intercepts, that's two ordered pairs. But as is, this equation, the numbers in it really don't have any meaning by themselves when it comes to the intercepts of the slope. Now, there is a way to figure out the slope and the intercept based on the three numbers, but my point is the numbers as is don't have any inherent meaning for the graph of this line. So yay, standard form looks pretty, but other than that, it's not good for much else. However, there is one very convenient form of the equation of a line. And I get the feeling several of you may recognize it when we get to it. I know this because when I teach this class to class, when I teach this class face to face, and we started a discussion about slope, the first thing I ask everybody is, tell me anything you already know about slope or anything you remember. And one of the things people inevitably give me is what ends up being slope-intercept form. So I won't be surprised if you recognize it or if you even already know it. But I don't want to just put it out there and say, here it is, look at it. I want it to develop naturally, to develop organically, and give you the opportunity to see it before I go, oh, there it is, that's slope-intercept form. So we're going to start with an example. Consider the equation below. Y equals 2/3 x minus 4. Oh no, a fraction. Get over it. A, find the y-intercept. B, find the x-intercept. And C, find the slope. All three of these things we know how to do. We've already talked about how to find intercepts. And once we find both of them, we can use those to find the slope. So let's start with the y-intercept. Recall that the y-intercept is the point on a graph, the point on the coordinate plane where a graph crosses the y-axis. Now, of course, that's not a line, but this graph does have a y-intercept. And how do you get to be on the y-axis? Well, if you start at the origin and you want to stay on the y-axis, you cannot move left or right. You can only move up or down. So if I can't move left or right, that means my x has to be 0. That's a visual reminder that to find the y-intercept, you start by letting x equal 0 and solve for y. Let x equal 0 and solve for y. Not O, not the letter O, the number 0, and solve for y. So let's do that and see what happens here. If we let x equal 0, we'll do this in blue just because, then we get y equals 2/3 times 0 minus 4. You might hear my squealing guinea pigs in the background. 2/3 times 0 is 0. Anything times 0 is 0. And 0 minus 4 is -4. Now, technically speaking, -4 is not the y-intercept. It's the place on the y-axis where the graph crosses the y-axis. But as an intercept, it's an ordered pair. Now, you got to be careful, because sometimes a homework platform will ask you for an intercept as a single number, which in this case would be -4, or they'll ask it for you as an ordered pair. When you go to do your homework and they prompt you for intercepts, read the instructions closely to see if they want a single value or if they want an ordered pair. For our purposes, we're going to use an ordered pair. We started by saying let x equal 0, and we got a y-intercept of -4. Well, that was pretty easy because 0 is not that bad to work with. Killed the 2/3 the minute I touched it with the 0. Now let's find the x-intercept. And along the same lines of thinking, recall that if a graph crosses the x-axis, then that point on the x-axis could not move up or down any, otherwise it wouldn't be on the x-axis. So to get to an x-intercept, you can move left or right, but you cannot move up or down. That means that your y-coordinate is 0. So in case you forget how to find the x-intercept, just remember the picture and ask yourself, what has to be true about your ordered pair to stay on the x-axis? And the answer is you let y equal 0. So we're going to let y equal 0 and solve for x. That's going to be a little bit trickier because we're putting the 0 where the y is. And so the fraction lives, but we've fought this battle before. A fraction is just a division problem, so when it comes time to get rid of it, do the opposite of division. But first, let's start by adding 4 to both sides. To cancel the -4, on the left, that gives us 0 plus 4 is 4, and on the right, it gives us 2/3 x. Now, at this point, you can actually do one of two things. You can get rid of the 3, or you can get rid of the 2/3. If you prefer dealing with individual numbers instead of ratios, aka fractions, then I would recommend multiplying both sides by 3 to counteract the divide by 3 move invoked by the 2/3. Remember, you can cancel parts of multiplication problems, so multiplying by 3 will achieve getting rid of the fraction. On the left side, we have 3 times 4 is 12. On the right side, we still have the 2 on the top of the fraction. The 3's canceled, and we're left with x. And so now we just have 12 equals 2x. That's a pretty easy one to finish. Divide both sides by 2, and we get x equals 6. So what does this mean? Well, it means our graph crosses the x-axis at x equals 6. But in terms of an ordered pair, the x-intercept is x was 6 when y was 0. Don't let the line break between x and intercept, but because of the spacing, it's just going to have to do. All right, so far we got a y-intercept of 0, -4, and an x-intercept of 6, 0. Let's find the slope. Remember, to find the slope of a line, we only need 2 points. And based on the work that we've already done, we found 2 points. We found a y-intercept of -4 and an x-intercept of +6. So we'll just kind of roughly approximate where these things are. -4 is about down here somewhere. +6 is over here somewhere. So we just need to connect those 2 points to form. Looks like I got a little bit off line there. Let's see if we can get it lined up. There we go. That's good enough. All right, so that was our x-intercept, and I believe it was. X-intercept was 6, y-intercept was -4. So we've got exactly what we need to find the slope. All we have to do now is use the slope formula. Now, because we have a picture, you could draw the rise and the run and count them. But, if we got ordered pairs, why not? Why not just use the slope formula? Speaking of ordered pairs, the ordered pairs are actually 6, 0, and 0, -4. And if I was drawing it, I wouldn't bother writing the ordered pairs, but knowing I'm about to calculate the slope using the formula m equals y2 minus y1 on top of the fraction and x2 minus x1 on the bottom of the fraction, it would be nice to see some x's and y's. And it matters not which one you call x1 or x2, just choose one and stick with it. For example, I got the 0, -4 first. So I'm going to call the 0 x1 and the -4 y1. And then since I got the 6, 0 second, I'll call that x2 and y2. Although honestly, it doesn't matter which one I call first, which one I call second. I invite you to, once we calculate the slope here, well, first I invite you to pause the video and calculate the slope. But once we do, I invite you to recalculate the slope by switching who we call first and second, and you'll see that we'll end up getting the same solution. All right. I like to write the fraction bar and the 2 minuses first and then drop everything in. My second y is 0. My first y is -4. Be careful, there's already a minus. So I'll put the -4 in parentheses to indicate that I'm subtracting a negative. And in the denominator, the second x, which is 6, minus the first x, which is 0. Well, this is pretty easy to do. The bottom is just 6 minus 0, which was 6. And on the top, when you do minus and negative, it's like plus a positive. That's actually the definition of subtraction, is to add the opposite. And so we end up just getting 0 plus 4. Well, 0 plus 4 is just 4. That was easy. Thank you, 0. Oh, but we have a fraction that can reduce. 4 over 6 can reduce to 2 over 3. And so our slope is 2/3. Text, please. Thank you. So the slope is, and we'll go ahead and call it m equals 2/3 because that's our variable for slope. All right, so none of that was too terribly bad, but why did I take us through that? Well, look at the summary of the results. When we had y equals 2/3 x minus 4, we got a y-intercept of -4, or 0, -4. We got an x-intercept of 6, 0, and a slope of 2/3. Look at the results. Now look at the equation. Look at the equation. Now look at the results. Notice anything? Well, the y-coordinate of the y-intercept is precisely the number that was at the end of the equation. And that's not an accident, because when we put in 0 for the x, it basically took off this and left us y equals -4. So no big surprise there. But what might have been a surprise if you weren't expecting it is that the value we got for the slope, 2/3, happened to be the coefficient of the x. I'll tell you right now, it's not a coincidence. Anytime you have an equation in the correct form, which I'm about to reveal, the number in front of the x is the slope, and the constant term at the end is the y-coordinate of the y-intercept. So this equation contains the slope and an intercept, the y-intercept in particular. So it's no surprise that this is called slope-intercept form. And it goes something like this. Now, most people will say that slope-intercept form is just this thing that I'm about to put in a red box. And they would not be wrong. But if I just write y equals mx plus b on a board somewhere without any context, then it doesn't have to mean anything. So I like to put a little bit of oomph on it with some words. If the equation of a line is y equals mx plus b, then the slope is m and the y-intercept is 0, b. Hence the name slope-intercept form. But this also works in reverse, meaning that if the slope of the line is m and the y-intercept is 0, b, then the equation of the line in slope-intercept form is y equals mx plus b. In logic, this is what we call a biconditional. This is actually something we discuss in my contemporary math classes, but it's an if-then that goes both directions. If the equation is this, then this is the slope and intercept and vice versa. Or as one big sentence, we could say, if y equals mx, can't even start it that way. The equation of a line is y equals mx plus b if and only if the slope of the line of the m is m and the y-intercept of the line is 0, b. So it's a two-way proposition. That box needs to come back, please. It's a two-way proposition. If this is your equation, then this is your slope and intercept, and vice versa. So we can not only extract information from a line, we can also build the equation of a line, as we'll see here in a moment. But let's start by doing some easy questions. Find the slope and the y-intercept of the following lines. Let's start with, I invite you to pause the video and see if you can find the slope and the y-intercept. One's pretty obvious. The second one, maybe not as obvious, but not that hard to see. And the third one, you'll be like, that's not right. Okay. Let's pause video. Why not? Should have tried it. All right, recall that slope-intercept form, just to make sure we're all looking at the same thing, is y equals mx plus b. So the number in front of the x, if it's in this form, is the slope, and the number at the end is the y-coordinate of the y-intercept. All right, actually, well, I'm not going to do it now. I'll do it after this. So what's the slope? -2. And the y-intercept is, as an ordered pair, well, if you said the y-intercept was 7, I know what you mean. And the homework may accept that unless it asks for an ordered pair, in which case you would say 0, 7. What I meant to do, and you don't have to change the problem, but what I meant to do was make it a -7 so that I could say the following. If you want to change it to -7, that's fine. If the number at the end is negative, that simply means that it's a negative y-intercept. Even though it says plus b up here, you have to be a little bit flexible with that plus sign, because this value of b might actually be negative, in which case plus and negative is the same as minus. So whatever number is at the end, if it says y equals mx plus b, that's the y coordinate of your y-intercept. What about example b? Y equals 4/9 x. Now you may question whether or not this is in slope-intercept form because there doesn't seem to be a number at the end. But the truth is, there is. Because if you can't see the number, it's usually because it's a plus 0. Now you don't have to physically write the plus 0 in there, but it justifies that it is in slope-intercept form, and the slope is in front of the x, so the slope is 4/9. And the y-intercept is 0, comma, the number at the end, but the number at the end is also 0. So if you don't see the plus b at the end, it's because it's equal to 0. But what about c, 2x plus 5y equals 13? Now, if you said the slope was 2 and the y-intercept was 13, no and no. Why? Well, look at the equation and look at slope-intercept form. These are not the same forms. In fact, part C is in standard form, ax plus by equals c. So why is it not in slope-intercept form? What's wrong with it structurally? Well, slope-intercept form, the guy at the top there that's flashing, has a very particular look to it. Specifically, the y is by itself on one side. And that's not the case down here. The y is not by itself here. So guess what we need to do? Well, if we're going to pull the slope and the intercept out of an equation of a line, and it's not in slope-intercept form, we can get it into slope-intercept form by solving for y. So we're going to rewrite in slope-intercept form. And you know what? I'm going to introduce something in this video, in this part. I should have introduced it earlier because it's so much easier than typing out slope-intercept form. I'm going to start abbreviating it SIF, which makes sense, slope-intercept form. But rewrite in slope-intercept form by solving for y. So we're going to have to solve this for y, and it looks like it's a challenging task, but I think I have enough room. Let me see. No, not enough room there. We'll just do it here. 1 second. Okay, I moved everything up to give myself a little bit of room. All right, so how do we solve this thing for y? Well, you can do it in 2 moves. Move number 1 is to get rid of the x terms. In other words, move the x terms from the left to the right. And we can do that by using an addition or subtraction move. In this case, we can do a minus 2x on both sides. The consequence of that is it cancels the 2x's on the left and leaves a 5y. And on the right, we have 13 minus 2x right here. But those aren't like terms. I can't combine them and get 11 of anything. The only thing I can do is write them next to each other. And since I'm trying to put this in slope-intercept form, I'd like to write the x part first. So we'll write the negative 2x first, and then plus 13 since the 13 is positive. We're closer to slope-intercept form, except it doesn't say y equals. It says 5y equals. But we know how to get rid of things that are multiplied, or at least we should by now. All we have to do is divide both sides by 5. But this is where you have to proceed a little carefully. 5's cancel. And notice that we have y equals negative 2x plus 13 over 5. Well, there's nothing technically wrong with saying y equals negative 2x plus 13 over 5. Except it doesn't quite look like it's in slope-intercept form because it's supposed to be something x plus something or minus something, if you will. And right now it's something x plus something over 5. So how can we take this thing that's not technically in slope-intercept form and make it in slope-intercept form? Well, the quickest way is to unadd the fractions. In other words, split this into 2 fractions that have the same denominator. So negative 2/5. And we'll go ahead and put the x to the right of it. It was originally on top, but when you're multiplying with fractions, anything on top can come out to the side. Not on the bottom, but anything on the top come out to the side. Plus, and then rewrite it as 13/5. All right, when we were solving quadratic equations and simplifying complex numbers, this is a move we've done already. Split it into 2 fractions. Oh, does that answer the question? Not really, but what it does is it puts it in slope-intercept form. But remember, the question we were being asked is what was the slope and what was the y-intercept? And now that we're in slope-intercept form, specifically this part over here, we can now answer what the slope and the y-intercept are. The slope is -2/5, and the y-intercept, I'm going to run out of room, is 0,13/5. I know it doesn't look like I'm running out of room, but right in that lower right-hand corner is where I go from page to page. So I'm going to move this over just a little bit. Our slope was -2/5, and the y-intercept is 0,13/5. I have a subtle challenge for you, and it's not that hard with this particular example. Remember when I said standard form doesn't contain the slope or the intercepts or anything? Well, I sort of lied. It does if you know where to look. So my challenge to you, and this is just something to think about, is look at where we started and look at where we ended and see if you can speculate how you can get the slope and the y-intercept or even the x-intercept out of standard form. All right, a little bit more about slope-intercept form, and I'm going to turn off my picture so that I can raise this. Let's just grab all this and move it upwards. There we go. Slope-intercept form is very useful for graphing a line if you interpret the slope as rise over run. For example, and I'm going to bring my picture back. I'll just put it somewhere that doesn't cover the words. Put me down here. Hello up there. For example, graph y equals -2/3 x plus 7. Well, we can graph anything by finding dots and connecting them. But we could also take advantage of the fact that this is in slope-intercept form. And how can we take advantage of that? Well, like this. Our slope is -2/3, and I'm going to put the negative on top. And our y-intercept is 0,7. If we interpret the slope as a ratio of rise over run, we can say the rise is -2 and the run is 3. And that's why I decided to put the negative on top, or rather the negative on one side of the fraction, because if I put it in front, then it doesn't belong to either number. But if I put it with the top or with the bottom, then it either belongs to the rise or run. I just think it's easier to put it on top. I can draw this real quick. All we have to do to draw this is set up an X and a Y axis. So let's do that. And I'm kind of thinking about where I'm going to put these things, so I don't need a lot of room, except in quadrant 1. I know my y-intercept is at 0,7. So I can go 1, 2, 3, 4, 5, 6, 7. So there's my y-intercept. But if I interpret the rise and run as movements from that point, a run of 3 means that I would go 3 to the right. So let's just, well, first off, let's mark up the x-axis. That would be kind of useful. And we would just need to go 3 to the right from where we currently are. So 1, 2, about that far. So there's our run. And then from that point, we would rise -2. But to rise in negative means to go down. So from here, we're going to go down to about here. And that would represent a rise of -2. And this will take me to another point on the graph here. And if it were drawn accurately, that would be the point, looks like over 3, up 5. Why did I say rise -12? What is that? I can't let that slide. There we go, rise -2. Of course, our y-intercept was at the point 0,7, so we could label that if we wanted to. But by using the y-intercept as a starting point, and the slope as a set of instructions, run and rise, I can locate a second point through which I can draw my line. Here we go. Actually, you know what? We can make a double-headed arrow because we can. And we should, because technically that line goes forever. And just like that, we've drawn the line. All we needed was a point to start with and a slope to get us to a second point to connect. So slope-intercept form is very useful for graphing a line if you interpret the slope as rise over run. Just remember, if the slope is negative, put it either with the rise or the run. I prefer putting it with the rise because I always like running to the right. That's just my preference. If you put it on the run, you would go left, but then your rise would go up. One other thing about slope-intercept form. You can also determine the slope-intercept form of a line if you have the slope and a point that's not the y-intercept. If you have the y-intercept, it's easy. Stick it in there and where the b is, and then put the slope in front of the x, and you got the equation of the line. But if you don't have the y-intercept, you don't know what number to put in for b. For example, find the equation of the line whose slope is m equals 3/4 and contains the point 8, -1. It is worth mentioning that this is not the y-intercept. And you can tell because to be the y-intercept, your x has to be 0, and this x is not 0, it's 8. So how can we use slope-intercept form, or how can we find slope-intercept form if we don't have the y-intercept? And the answer is to start with y equals mx plus b. Now, what do we have? We have an m and we have an ordered pair, but isn't the ordered pair just an x and a y? We can let m equal 3/4, x equal 8, and y equal -1. Then we can solve for b. So this is actually pretty easy. Let's skip that capital E out of there. And let's make myself a little bit of room. We'll just move this guy up. Okay, so let's give it a try. Let's start with y equals mx plus b. You hear a squeaky noise. This is my dog playing with the squeaky toy. Let's put in y equals -1, m equals 3/4, x equals 8, and then plus b. And we can solve for b. The first thing we need to do is to figure out what 3/4 times 8 is. And if you need to take it to the side, then take it to the side. 3/4 times 8 could be viewed as 3/4 times 8 over 1, which would give us license to reduce. 4 goes into 8 2 times. On the top, 3 times 2 is 6. On the bottom, we have a 1. 6 over 1, of course, is equal to 6. So you can do the work to the side, or you can just do it mentally, or a calculator if you know how to use it correctly. But we get -1 equals 6 plus b. And this is a real easy equation to finish now. We just have to subtract 6 from both sides. That will cancel the 6's on the right. On the left, we get -1 minus 6 equals -7. So we end up getting -7 is equal to b. We found the y-intercept. That means our slope-intercept form is, time to move me around, y equals m, which was 3/4 x plus b, but since the b is negative, we'll write -7. So slope-intercept form actually has a lot of uses. It's a simple way to describe the equation of a line. It's easy to build if you have a slope and an intercept. If you have it, you can use it to graph a line. If you don't have it, like you have standard form, you can make it in slope-intercept form. If you have a slope and not a point, then you can still use slope-intercept form. Set it up, plug in the m, the x, and the y that you have, solve for b, then you can say what slope-intercept form is. And that is the end of this video and the end of the videos for homework 5.4, I believe it was. If you got any questions, you know how to get a hold of me.